All right, welcome to The Explainer. Today, we are tackling a big one of the most important books ever written, Charles Darwin's On the Origin of Species. Now, Darwin himself called it one long argument, and that's exactly how we're going to approach it. We're going to follow his logic step by step and see how he built his case.
So where do we even start? Well, just like for Darwin himself, our story begins on a ship. During that legendary 5-year voyage on the H.M.S. Beagle, he wasn't just collecting plants and animals. He was collecting questions. He was seeing things out there, especially in South America and the Galapagos, that just didn't quite add up with the accepted idea that every species was just created, fixed, and unchanging.
And that's what set him on his path. Those observations sparked a mission. When he got back to England, he was totally obsessed with solving what a famous philosopher at the time called the mystery of mysteries. Seriously, where do all the different species come from? It was this giant puzzle that he would dedicate the next 20 years of his life to solving.
So, to crack this huge natural puzzle, Darwin's first big clue came from, well, a pretty unexpected place. Not from some exotic jungle, but from the farms and backyards of England. He started looking really closely at what humans had been doing for thousands of years.
You know, Darwin was absolutely fascinated by pigeons. He even became a pigeon breeder himself just to see it firsthand. He saw how all this incredible, wild diversity — you've got the pouter with its giant inflatable crop, the fantail with its crazy peacock-like tail, all of it, every single breed, came from one single ancestor, the plain old wild rock pigeon.
But here's the crazy part. The actual experts, the breeders who were creating these new forms, they were totally convinced that each of their breeds was its own separate, distinct species. They'd laugh in your face if you suggested otherwise. And this was a huge light bulb moment for Darwin. It showed him how a bunch of small, accumulated changes could eventually create something that looks like a completely different animal.
So Darwin gave this whole process a name, artificial selection. And the idea is actually pretty simple. You've got a farmer, he sees a sheep with slightly better wool, or a pigeon with a slightly fancier set of feathers, and he makes sure that's the one that has babies. You do that over and over, generation after generation, and those tiny little variations start to add up.
In fact, one writer at the time put it perfectly. He called this power of human selection a magician's wand. It was like humans could literally sculpt life, creating whatever form they wanted. This was the first crucial piece of Darwin's puzzle. A selecting force can cause huge amounts of change.
Okay, so this led Darwin to a massive question. If humans can be this powerful force for change, could nature have a force of its own? A much, much more powerful one. And that question pushed him towards his next big insight. He realized something that's true for every single living thing on the planet. They all produce way more offspring than could ever hope to survive. I mean, a single orchid can make millions of seeds. Even elephants, the slowest breeders we know of, could completely cover a continent in just a few hundred years if every single one of their babies survived and had more babies.
But obviously, that doesn't happen, right? The world isn't buried in elephants. And that's because resources, food, water, a place to live, they're all limited. So this simple fact automatically creates a constant, relentless competition. He called it the struggle for existence.
And just how tangled is this struggle? Well, Darwin came up with this brilliant little example. He showed how the number of cats in a town could actually affect how much clover grows in the nearby fields, all through this chain reaction involving mice and bees. It's a perfect illustration that life isn't some simple chain. It's a super complex, interconnected web.
And this leads to a really, really important point that Darwin made. Yeah, a fox struggles against a rabbit, sure. But the toughest competition, the most severe struggle, is actually between fox and fox, or rabbit and rabbit. Why? Because they're all fighting for the exact same food, the exact same territory, and the exact same mates.
Okay, so let's recap. Darwin's got his two main ingredients. You've got variation everywhere, and you've got this constant struggle for life. Now he puts those two things together, and finally he can describe the engine that actually drives the creation of new species.
He called it natural selection. And really, it's a pretty straightforward idea when you break it down. In that huge struggle for existence, if an individual happens to be born with some tiny little variation that gives it an edge, maybe a slightly sharper beak or slightly better camouflage, it's going to have a better chance of surviving and having kids, and it'll pass that useful trait on. On the flip side, any harmful variations tend to get wiped out.
So this is really the core of his whole argument. Natural selection is for nature
what a human breeder is for his pigeons, but it's on a totally different scale. Where a human's efforts are, as Darwin said, feeble, nature is a power that is incessantly ready for action. It's not selecting for what humans want, it's selecting for the good of the creature itself. And it's not working over a few centuries, it's working over immense geological time.
Now, Darwin was smart. He knew people would have a hard time with this, and he went straight for the biggest challenge he could think of: the eye. He admitted that the idea of something so perfect, so complex, evolving through this process, well, it seemed, in his words, absurd in the highest possible degree.
And his answer was just brilliant. He said, look, my theory only falls apart if you can prove there's no possible series of small gradual steps to get here, where each and every step was useful. Think about it. A simple nerve that can just sense light is better than nothing. A small pit that can tell which direction the light is coming from is even better. Add a simple lens, and so on. Our imagination might struggle with it, but Darwin showed how, one tiny advantageous step at a time, it's not impossible at all.
So once he had this powerful engine, natural selection, it was like he'd found a master key. Suddenly, all these weird biological puzzles from all over the place started to unlock. This one big idea didn't just explain one thing, it started to explain pretty much everything.
Take homology, for instance. All of a sudden, these strange similarities just made perfect sense. I mean, why on earth would a human hand, a bat's wing, and a whale's flipper all be built from the same basic set of bones? That's not the most efficient design for each job. The answer? They all inherited that basic blueprint from a shared ancestor, and natural selection just tinkered with it for different purposes over millions of years.
And it also solved the very puzzle that started him on this journey. Why did the animals on the Galapagos Islands look like, well, slightly weird versions of the animals on mainland South America? They weren't just created there. No, they were the distant descendants of animals that had somehow made their way from the continent and then, over countless generations, were slowly modified by natural selection to perfectly fit their new island home.
And this all builds to Darwin's most profound and I think most beautiful conclusion. It means that all life, everything, from the tiniest microbe to the biggest blue whale, is part of one single, gigantic branching family tree. We're all related. We're all distant cousins, connected by this simple, powerful process. As Darwin himself wrote, there is a grandeur in this view of life.